Hey everyone, thanks for joining. Let's give it a couple minutes and then we'll get started. Thanks. If you're just joining us, we'll give it like 2 minutes and then we'll get started. Okay, I guess we'll just get started. It seems like we have everybody here. So, hi, my name is Aaron. I'm the PMM for the Places product here at Foursquare. Today we're going to be talking about our geosummarizer and attribute confidence scores, and as well as some other improvements that we've been doing in the past few months here. It's really exciting data quality improvements. And with that, let's start with some introductions with the team that actually has worked on the product. So they're a lot more skilled than I am. So we have Zizis Petru, who's our senior engineering manager on our Places product. And sorry, getting over a cold, so my throat's a little shot. Sandhya, she's our senior product places manager. James Bogart, who's our data developer for the ingestion for our places engine. And then Saurav, who's the senior data scientist for places. And with that, our agenda will be data quality improvements. So we'll just discuss what we've actually done to improve the data quality here at Foursquare. And then we'll go a little bit more in depth on the geosummarizer and attribute level confidence scores. I would love to tell you about those, but we have people that are way smarter than me. So let's get into it with Sandhya.
Yeah. Hi, everyone. So the past year, we have been doing multiple things on our on improving our data quality for all the points of interest, which we'll be referring to as POIs. So some of the improvements were, I think, like the geosummarizer. So lat longs become like an important part for us to show where a place is and how we see the real world. And so that was on the lat longs. Then there is the attributes. Every POI comes with a multiple attributes. And we have certain confidence scores. And there are some other improvements that we do on closed and venue reality, like if a POI is open, closed, and is it open to public, and we have data from multiple sources. So yeah, how do we determine the quality of these particular sources? But for today, we will keep our discussion to the first two things, and Soon we will probably talk about our closed NVRS and source quality scores with all of you. Next slide, please, Aaron. Yeah. So why do we do the attribute level confidence score? And yeah, so like I said, every POI comes with like multiple attributes, say like a name, it has an address, it has a certain postcode, region, locality, lat long, website. So there are multiple things that describe what a place is in a real world, multiple identifiers. And we have data coming in from multiple sources also. So when things come in from multiple sources, how can we pick the best source, and how do we eventually know which one is right? So yeah, so for each of these, it kind of becomes like a very different combination, and there's a lot of complexity involved because every country works differently, and in fact, every place probably within a country works slightly differently, and we need to take a lot of that into account in our data to make it like a mission, where a mission can learn continuously based on some of the rules that we give them from the real world. So yeah, so this would give you so attribute level confidence scores itself will give you like a percentile, like how confident we are about the certain attribute. Say you get an address for Malaysia, and how confident we are, like are we 99% confident, 90% confident about the data, and you can use it to slice the data for your needs, like how accurate information do you want for your for your project. And yeah, next is the yeah, so
Sorry.
that was about the attribute level confidence score. And then moving on to the geocode summarizer, why we have one. And like I said, we have various inputs. Say we have a lot of users checking in on our Swarm app, like millions of users checking on a Swarm app directly daily. And there are a lot of third-party crawls also that we do from a lot of open source websites. And how do we choose that final lat long to show the exact location of a place, an accurate exact location? And this helps a lot of our customers in navigation, and when they do a lot of then the mapping and delivery, right? So delivery services like DoorDash and other companies, they actually use this, some of the data that we have, the lat longs, for delivering to the right places, picking up and delivering from the right places. So yeah, so hopefully this helps you build a more accurate location-based product. And I will give it over to Saurav to talk to you more about the geocode summarizer, how he built a lot of it. Yeah.
Thanks, Sandhya. Aaron, if you could go past the slide to the next one. So like Sandhya was saying, we at Foursquare ingest a lot of data from multiple sources, right? And each source can have its own representation for where a place should lie on the map. So the objective of the geosummarizer is to summarize all of these sources and find that one singular representation for the lat long or the geocode of the place. How we do that is a multi-step process that's kind of outlined on the slide, and I'll try to walk through it in as much detail as I can. But it all starts with discretizing the map into a grid so that we can work with smaller units of spatial context. And by spatial context, I mean our view of the physical world. So things like where are the roads or where are the buildings. But once we have that information, then we can featureize each of these small building blocks into vectors of numerical attributes. Right? And what these attributes are is highly driven by domain knowledge and a lot of experimentation. But at the end of this step, we've converted all of our inputs into this matrix of numbers that can be fed into any machine learning algorithm. But in addition to having this input matrix X, we also need an output that we predict on, the Y variable, right? And the geosummarizer is modeled as a regression task. So the Y variable is a real number, and that's computed using a score, which is essentially a function that measures how close a point is to the ground truth. The exact functional form of the score is a bit of a secret sauce that we have developed over the years, but essentially a larger score would mean that the point is closer to the ground truth and vice versa. So now we have this input matrix X, we have this output variable Y. We can now learn a function that maps the input to output. Or in other words, we can do machine learning with all of its bells and whistles, right? So think feature selection and hyperparameter tuning and model selection and all of that good stuff. What goes hand in hand with training these machine learning models is evaluation. And we do a lot of it, right? All the way from the caveman way of looking at individual predictions and seeing what's working and what's not, to more sophisticated, automated ways of error analysis, like learning curves or computing feature importance scores. Once you have the algorithm, though, you can make these predictions on these cellular level, like these small building blocks of the grid. And we use the max prediction, the highest predicted value of each of these cells, as our final lat long for that place. With all of the model evaluation and training and predictions, once we are satisfied with the numbers, we then decide to release our new models into production, and a new data set is created, which is then shared with all of our clients so everyone can benefit from all of the hard work. One thing I'd like to point out here is the scale of all of this work, right? Massive data sets, multiple machine learning models being trained. We have almost one model per country. So setting up all of the infrastructure and maintaining all the various pipelines is all part of the job. With that said, I'll hand it over to James to walk us through some numbers.
Okay, so I'm going to be going over some of the metrics that I was just discussing that we use to evaluate our models. This slide particularly is what we kind of consider our internal metrics. We have a large suite of metrics that we use to track precise changes between the model, between iterations, and tune it, see what we can fix. But generally, when we just want to communicate broadly the progress of a model iteration, we use these two metrics, which is the median distance to annotation and the mean score that Sarah was talking about earlier. So yeah, for each of the data sets, we have a continuous process of gathering hand annotated annotations, which represent the centroid of a POI in the real world. And these are POIs that match our data. So we can kind of use them as a gold set and derive some of these metrics about the model. Once the model makes the predictions, we can compare them to these annotations. So we use these two metrics internally. The median distance, which is essentially what it sounds like. We calculate the median distance for all annotations within a particular data set. For all predictions within a data set, we calculate the distance in meters to the annotation point. And we can see that value is overall decreasing between the production baseline and the release candidate metrics. That's good. We want that metric to go down because that means we are getting closer to that centroid annotation. And then we also have this mean score, again, which I won't go into too many details about, but it allows us to have heuristics and define some criteria, which we can use to assign a score from 0 to 1. Obviously 0 is worse and then 1 is better for this score. So if you look at the comparison again, we'll see that generally these scores are increasing across the board between production and the stage 1 release. So while we use these two metrics internally kind of to communicate like as we progress models, when we do client-facing metrics, we have some other metrics on the next slide that are a little bit more general and easily defined. So we kind of, when we release client-facing metrics about the models prior to release, we kind of really just define these more general metrics. We break down the predictions into whether they are on the correct building, or if they were maybe on an incorrect building, or if they were off of any building, but maybe on something like a parking lot or sidewalk or somewhere in the POI lot, and how the numbers change between iterations. So if we look at this table on the left, we can see the percent of the annotated entities that moved from the wrong building to the correct building, and also moved from somewhere off a building onto the correct building, respectively, for each of the data sets. And in the parentheses, you can see that number projected onto the full sample of the quality POIs that we generally deliver to clients. But again, remember that the percentages are of the annotated sample that we have for each of the data sets. We also have this other metric, the net gain, which we use. It's really kind of just the ratio to gain in correct predictions. So you can see the formula at the bottom of the screen, but it's the percent of correct predictions after we have predicted for the model to the percent of, or I'm sorry, the number of correct predictions before divided by the total number of correct before. And you can see the net gain is all positive for these data sets, but specifically Japan, we saw a pretty large increase there. Good performance on the model for these candidate there. So that's it for the metrics here. I can pass it off to Zeus about the attribute scores.
Thank you, James. Aaron, can you move to the next slide? Thank you. So before talking about the way that the attribute level confidence scores are defined, it is important to mention how these attributes are generated at Foursquare. So as you all know, Foursquare, and as Sandhya mentioned, Foursquare ingests a number of information of POIs from different sources. We ingest sources from the web. We have edits submitted by users. We have providers specifically that we call listings indicators, and all of those give us information about different POIs in different countries. I draw an example here on the right part of the slide, where pretty much represents having different sources sending us the address in this example for the same place of interest, the same POI. The way that we combine this address, we call it internally summarization, and it is a process that takes into account the sources that they generate these addresses. And we have a voting mechanism, which is not part of today's discussion, that chooses the best attribute as we think it is. So now the question comes, after we did this summarization and we selected the attribute for specific POI, how confident are we that this final attribute is correct, knowing the sources that it came from? Next slide, please. So this leads us to the attribute confidence scores that they work on the, we call them attribute level confidence scores because they work on the attribute side. For each one of the attributes, like the address, the name, we try to calculate one score that expresses this confidence. Under the hood, we run a large number of evaluation of the inputs that we are getting from different sources. And this is done on the most granular level. We evaluate the different sources based on each specific attribute and each country we get them from. So we come up with mean, average, let's say, support scores for each source in a specific country and for each specific attribute. So what we did then to calculate these attribute confidence scores is that we created an algorithm that is inspired from the veracity problem. This is the problem where we have several informations about a specific attribute that can also be conflicting. So we created an algorithm that takes into account the sources that agree with the selected attribute value that comes from the summarization, and we upvote these sources. We weigh them in a positive way. Alternatively, we also take into account the sources that of this POI and this attribute that disagree with the selected attribute. There are inputs that did not get chosen, and they suggest a different value, a different address, for example, for a certain POI. So we weigh those appropriately, and pretty much we penalize the score. The more conflicting inputs that we have for certain POI, the lower the overall confidence for this attribute of the POI, because the sources that we have do not agree. On top of that, we have also implemented a time decay factor for all of those sources. And this is in order to favor sources that we ingested recently. The information that we got recently that we believe it's more accurate and it should override previous information. In the opposite way, we want to penalize information that has been stale, that we have not ingested for a while. Inputs that we got several years ago, that it is very possible that they are not correct anymore, or that will give us a signal of sources that we want to put some extra focus and try to ingest again, or give us a sense of inputs that have been there for a while and we need to update and focus on next release cycles. So these scores, as Sandhya mentioned, are both for internal improvement and also to help clients make better use of our data. In the end of the day, after we extract these scores, which are real values, let's say from 0 to 1, and express a probability similar measure of how confident we feel, we group those scores in percentiles, like the 99th percentile, the 90th percentile, the 75th, and so on, and so forth. And this is what we plan to export and release to clients, so that clients can then use these percentiles to conveniently go and create slices of data based on the minimum precision that they want to have for POIs and the trade-offs between recalls. This means that slicing on the top percentiles is expected to give you, let's say for addresses, the POIs where we feel best about the address, we feel most confident, but it will also cut off some other addresses. So each one then, depending on their own needs, can weigh in and slice the data in the way appropriate. Next slide, please. This is a quick slide. We're running a bunch of evaluations. So this is a snapshot of the evaluations that we are running on these percentiles. As you can see in this slide, the precision of the different percentiles, so how correct the actual attribute is given ground truth information, follows the pattern that we expect to follow. The highest percentile, in this case, the ones that the top 1% of the POIs for a specific attribute come up with the highest precision, and then the precision decreases as we go into lower percentiles. And this pretty much comes in hand with the slicing options that we have there. If we want to increase the recall and get more POIs in our dataset in our downstream jobs, then we go further down on the percentiles and include those POIs in our analysis and pipelines. And this is pretty much the suggested use there for the clients and the way that these scores can increase the quality of the data used in downstream jobs. And that's all for me. I pass it back to you, Aaron.
Okay, so now is the fun part, the question and answers, and we have a few coming in, so I'll take them as they come. The first one is, how is the percentiles distribution determined? I believe this is for you. I think they're both for you right now, Cesius.
Yeah, it is product driven so far. So and we are flexible to accommodate needs and change it. For the first preliminary round, we set those after some discussions on the product side and some preliminary discussions with some clients. And we decided that these percentiles of 99, 90, 75, 50, and the remaining ones are what pretty much came after the consensus. Now this is not graved in stone, and it's something that we can change based on client requirements and deliver different percentiles and different cuts of the attribute level scores and different rankings that that can pretty much follow the needs of each user. It is a proposal so far. The raw scores are there. The way that we group them into percentiles is something that we are flexible for. And this is the first iteration that we came up after consultation with clients and internally.
Cool. And now our few other questions. It's how do you determine the ground truth?
I can take that one. So when we have a third party and internal team that is continually collecting annotations for us by comparing different sources and trying to determine, at least for lat longs, what the best lat long is for a place. When we provide samples to annotate, we make sure that we are uniformly sampling entities across the quality cut of the data. We make sure we filter out the quality cut first, because that is the most common client-facing product that we have, is the quality cut, which are the more popular POIs. So we want to make sure that the model is at least considering those most importantly. But once we make that cut, we are trying to sample uniformly across POI types or categories to reduce bias there, and as well as, especially for the lat longs, to make sure that we sample across a varied spectrum of geographic areas, so dense areas and rural areas, just to make sure that we're reducing bias as much as possible in that geosummarizer model. And we use the very similar systems to derive annotations for the other models we have, such as the attribute scores.
Awesome. And then the next one is, what is the machine learning model you guys use for the geosummarizer?
Sure, I can take that one. Without revealing too much, we found that ensembling works pretty well. So we use an ensemble model of weak tree-based models. So you can think something similar to XGBoost.
Sandhya, I believe this one might be for you, but how do you plan on improving the models, and is there a future roadmap that we can have some insights into?
Yeah, sure. So currently, like I said, Foursquare itself, our goal is to have the best representation of the real world, and that includes like a lot of complexity, which kind of goes with every region and every country across the world. Each one have their own unique ways of describing and demarcating places. So where we the currently for geosummarizer, we did like 6 countries where we know that we actually had a good improvement, and we had like a good sense of how these countries probably a better sense, right, how these countries are in the real world. And our focus for geosummarizer would be to continue to improve in the US, where we already have better sense, and also like we started doing in India, Southeast Asian countries, and China, like a lot of all the rest of the world, right? Apart from these 6 countries where we also think this could add. And once we get like more inputs, how the model performs in all these countries, I think that would definitely improve our accuracy even in the current selection of models. So basically, yeah, in short, for geosummarizer, continue improving on these 6 countries, but also focus on the rest of the world so that we kind of get all the uniqueness out there. For the attribute confidence score, again, we kind of come up in this country attribute pairs. That's kind of how we start targeting. So there are these countries, and there's like a list of attributes that we shared, like the name, address, lat long, how confident we are in each of it. And yeah, so over there again, it's like the plan is to yeah, the goal is to be everything should be 99 in the 99 percentile bucket. Our precision should be super high for every POI in the world, but that's not that's not that easy, I think, and it's not that easy to represent that complexity so quickly. So yeah, so eventually move everything to the higher precision bucket and be more good about it. And also the expansion that I mentioned from geosummarizer. So we have about 7 countries today. For 7 countries that we are doing all the attributes for, we want to expand to more countries. Yeah.
Cool.
Zeus, you want to add something? Yeah, sure.
No, pretty much you covered everything. The main part is that the attribute level confidence scores, as we talk about, rely on the evaluation of the sources. We've already run a huge campaign to evaluate sources in these 7 priority countries that Sandia goes, and we have ongoing evaluations of sources in other countries as well. So as they keep coming in, then we will be able to expand the attribute level confidence score coverage in other countries as well.
Awesome. And then I believe our last question of the day is, how was the attribute level confidence score methodology selected, and what approaches were evaluated?
Oh yeah, that also comes together with getting manual annotations of the POIs that we have. So we also collected a bunch of annotations coming from different sources, and in these countries that we talked about, we used some of those for running our models, and we kept an individual part there as a testing set. And this expanded data set, as it was growing, it was giving us the chance to evaluate several approaches on how to generate the attribute confidence level scores and evaluate how well they align with the expected ideal scores coming from ground truth. In other words, how well we identify, we assign high scores to attributes that were indeed correct, and vice versa. We tried different approaches, starting with the very simplistic ones, as generating these scores based on the agreeing sources and the average or the maximum scores that we were getting for the agreeing opses, to more sophisticated approaches like the one that we finally chose for. Even with this approach, we tried a bunch of different parameters that we high-tuned, and in particular, we experimented with the time decay factor. How long do we need to wait until a source gets essentially deprecated, and with which rate we should be deprecating resources based on the number of months that this source has not been refreshed. We experimented with internal ways of measuring distance of the dissimilarity and similarity of the source attributes to the ground truth attributes. We experimenting, for example, with exact string matching, with fuzzy ways of calculating the string matching, and we came up for a different set of parameters for each one of the attributes and each one of the countries that we finally go with. So pretty granular level there after a lot of experimentation.
Awesome. Okay, well, those are our questions for the days. Any listeners, if you guys have any further questions, feel free to send them in. You'll also be receiving a recording of this webinar. But yeah, once you get the follow-up email, if you have any questions, feel free to reach out to us and we'll be more than happy to help you. But that's it for today, and thank you for joining us.
Thank you all.
Thank you.